In this video, we'll introduce implicit differentiation with two variables. You did implicit differentiation in Calculus 1. Here, we take a slightly different approach using the chain rule to help us come up with a formula for dy dx. We'll start with a quick proof. Suppose f of xy equals 0 defines y as a differentiable function of x. Show that dy dx equals negative f sub x over f sub y, the partial derivatives of f, as long as f sub y is not 0. Since f of xy equals 0 defines y as a differentiable function of x, we can take the derivative of both sides with respect to x. So we have df dx equals 0. Using the chain rule, df dx equals partial f partial x times dx dx plus partial f partial y times dy dx. Because we are given df dx equals 0, we have this whole chain rule piece equal to 0. Now, we know that dx dx is equal to 1. So now we need to solve for dy dx. dy dx equals negative partial derivative of f with respect to x, because we subtract that term from both sides of the equation, divided by partial derivative of f with respect to y, because we divide both sides by this in order to get dy dx by itself. This is equal to negative f sub x over f sub y. This is what we'll use to define our implicit differentiation. Example: assuming y to the fifth plus x squared y cubed equals 1 plus ye to the x squared defines y as a differentiable function of x, find dy dx at the point 0, negative 2. Step 1. Get the equation in the form f of xy equals 0. We must have the equation in this form in order to identify the function f. We'll move everything to the left side of the equal sign, so we have y to the fifth plus x squared y cubed minus ye to the x squared minus 1 equals 0. Now the left side of the equation defines f of xy. Step 2, find dy dx equals negative f sub x over f sub y. F sub x is the partial derivative with respect to x of y to the fifth plus x squared y cubed minus ye to the x squared minus 1. Now, y to the fifth is a constant, since we're taking the derivative with respect to x, so its derivative is 0. Y cubed is a constant multiple, so the derivative of x squared y cubed is 2xy cubed. And y of the third term is a constant multiple, so the derivative of minus ye to the x squared is minus y, and then we use the single variable chain rule on e to the x squared. So minus y times x times e to the x squared times 2x. And then the last term, minus 1, is a constant, so its derivative is 0. Now, f sub y is the partial derivative with respect to y of y to the fifth plus x squared y cubed minus y e to the x squared minus 1. In this expression, the factors x squared and e to the x squared are constant multiples. So the derivative is 5y to the fourth plus x squared times 3y squared minus 1e to the x squared plus 0. Now I'll just copy these partial derivatives to the next screen. And we know that dy dx equals negative f sub x over f sub y. So I'll leave the negative out front, and then we have 2xy cubed minus 2xy e to the x squared over 5y to the fourth plus 3x squared y squared minus e to the x squared. Now our final step, step 3, is plug in the given point. So dy dx at the point 0, negative 2 equals negative out front 2 times 0 times negative 2 cubed minus 2 times 0 times negative 2 times e to the 0 over 5 times negative 2 to the fourth plus 3 times 0 squared times negative 2 squared minus e to the 0. Don't forget the parentheses around the negative 2 when raising it to a power in your calculator. And this is equal to negative 0 over 79, which is just 0. So use the definition dy dx equals negative f sub x over f sub y. Find your partial derivatives and then plug it into the formula. Remember, back in the first step, we had to get it into the form f of xy equals 0 before we could define our function.